Thank you very much. Hopefully everybody had a nice break. And indeed, we will tell you about the shelf life test that we did in the PHBV materials. But first, as well, an introduction of the partners of this work package. Now, Back to Food was already kindly introduced by my colleague, so I will not repeat, but maybe just to say that Back to Food wants to form the bridge between research institutes and then all the different stakeholders. Those stakeholders are, of course, our companies which are member, and as you can see, if you're interested to join, you can still join the consortium of Back for Food. What I want to highlight is that 2 of our members were actively involved as partners of this project, and those results will be introduced as well today. So it's Soredab and A.Vermeulen. Next to that, many of the other companies were also in the stakeholders platform of Glopack. Now, our role in Glopack was already introduced by Hedwig, so I will not repeat this. With this presentation, I will focus on the coordination of the shelf life test of the food products. But of course, this was in close collaboration with the food companies involved in Glopack. And the first one that I want to introduce is La Vie est Belle. Unfortunately, Matthias and Herman are not here today. They would have been, but COVID came in between, as you can imagine. But they are following online. So if you have questions for them, of course, they will answer it as well. So they produce organic, vegetarian, ready-to-eat spreads and burgers, fresh products which are not pasteurized, so packed on a modified atmosphere. They use at the moment 100% recycled PET on a manual and semi-automatic line. It's a relatively small company, small and SME company, but very known in Flanders. Then on the other hand, we have Soredab Group, which is member of this consortium, of Glopack consortium, but they will introduce in detail this afternoon by Grégoire, who is also here and will present the last presentation today. Particularly for this work package, it was the fine food meat part of Soredab Group. So they are a large producer of Belgian meat. And as you can see, there are more than 1,000 employees, of which 200 qualified butchers. And if you see the numbers of what they process every year on animals, it's huge. If you look to vegetarian products, delicatessen and charcuterie, so they produce more than 200,000 packages a day. And just to see the numbers of amount of material that they use every day. And also poultry they do. So that's Soredab Group. And then we have Florence. She will do also part of the presentation. She works for Soredab, and Soredab is the research center of the Savencia Group. You see here all the brands that they are responsible for to do new research, innovative research for all those brands of butter, cream, cheese, and chocolates. The role of those food partners we have clustered because it's more or less the same for all of them. And so they were mainly involved in work package 4, but they also helped out in the market replication test, which will be presented in the afternoon. And they also did some tests with the PHBV materials, which was also already mentioned in the presentation before. But we will focus on the shelf life tests. And before I will go into details of the results, I first want to give some small introduction on modified atmosphere packaging, because I know that not everybody in the audience is a specialist in that too. And then we will present the test conditions of the present or of the Glopack project with the results for each of the products. But first, some introduction to modified atmosphere packaging. So what we do, or what we want to do, is to change the air in the headspace of a packed product into a certain combination of CO2, nitrogen, and oxygen. And all of these gases, they have a different purpose in the modified atmosphere pack. And so the CO2 is the antimicrobial agent. If you don't add it, you don't have many increase in shelf life. The more CO2 that you add, the better the shelf life of your product will be. But the CO2 dissolves in the fats and in the water phase of the food product, and that can cause collapse. So give extra stress on your packaging material. If you add also too much CO2, it can also lead to discoloration, drip, or collapse. So if you look to the CO2 into your package, and this is important to understand the results that we will discuss later, first you have a decrease. Because the CO2 is dissolving in the product, so what you measure in the headspace is decreasing in the first hours after packing. And then you have an equilibrium for a few days or weeks, and then the CO2 will increase again because of spoilage, because microorganisms are growing and they produce CO2. So to counteract the collapse, we also use nitrogen in our mixture. That nitrogen is an inert gas, it will not react with anything, but it can eliminate the oxygen and can be used as a filling gas when CO2 is used to prevent the collapse of it. And then the third gas is oxygen. In most of the modified atmosphere packages, this oxygen is avoided. You don't want to have oxygen, except in certain conditions. For example, for the fresh meat, which I will present as well, we use oxygen to have the bright red color of the beef. Also for vegetables, they are respiring, they are shellfish, and they use oxygen, so you need to have some oxygen in your package, or also for marine fish to avoid the formation of ammonia. For all the other applications, it's better not to use oxygen. But of course, if we put a certain mixture of CO2, nitrogen, and oxygen in our package, and the outside is the air, we want to, there will always be some, okay, there are the lines, there will also be some interchange of oxygen, CO2, and nitrogen with the surrounding conditions, so in this case, air. If we have low barrier properties of our material, within a few days, we will have actually air inside the package instead of modified atmosphere. So we need to have packages which have a high barrier properties, particularly gas barrier properties, to avoid that we have too much exchange with the environment. So that was important for the materials in this project as well. And here you can see some results of the reference material of the shelf life test and also the commercial material. I just want to stress that all the packages are also in the back of this room, the reference packages as well as the PHBV material that we used. So the PHBV material was the PHI 003. We need some water, sorry. Okay, sorry. So we had the PHBV tray, the PHI 003, and also a lid film which was kindly provided by Natural. It was a cellulose-based, fully biodegradable film as well. So you see here the commercial materials and the reference materials that we use, and they are more or less in the same order of magnitude. Regarding the experimental design, as you can see, we had 3 food products: the falafel from La Piebelle, the red meat from Colruyt, and fresh cheese from Soredab. And they are a little bit, they are short shelf life products like the red meat, middle shelf life products, and then the long shelf life products, fresh cheese. So the temperature profile in which the shelf life tests were performed was depending on the shelf life of the product. We did many analyses, so many microbial analysis on the products, many chemical analysis as well. For sure, you will not present all the results because that would be a little bit too much. So we focus on the ones which are the most interesting. So the first result is regarding the falafel. As mentioned already in the presentation before, we often had leakages. So on the moment of packing, we already saw some of the packages which didn't seal very well. Those were left out from the beginning. But then during the shelf life test, we also saw that in some of the packages, really micro leaks appeared. And that's what you see here. You have clearly air inside your modified atmosphere packet. So no CO2 anymore and high oxygen concentrations. Now the full circles, they are the reference trays, and the others are the open symbols are the commercial PHBV trays, which we performed threefold the reference tray in singular. And if, as you can see, if they are well sealed, they even have lower concentrations of oxygen and higher concentrations of CO2, showing that the functionality, the gas barrier properties of the PHBV material is really good to be used as a modified atmosphere pack. So if we look then to the microbial analysis, we see in fact no clear difference, no significant difference between the reference tray and the PHBV materials, not for the total aerobic psychotropic count as for the total anaerobic psychotropic count. The only thing is that the moment that we had the leakage, you clearly see that the palatals are molding very fast. So this was already a clear indication that a leakage appeared, as molds will only grow when they have oxygen. There is no oxygen, the molds cannot grow. We also didn't have any evolution in pH during the shelf life. If we look to the fresh beef, here the story is a little bit different because the oxygen concentrations, they are very high because we packed them under very high super atmospheric oxygen concentration, so more than in the air, because we need the bright red color of the beef. But again, we had many packages with leakages here appearing, but if we didn't have any leakage, we clearly see that the barrier properties are very good to pack the fresh beef under modified atmospheric conditions. Regarding the microbial analysis, you see more or less the same. Here we show the total aerobic psychotropic count, so F.Berlier-Coulon and the lactic acid bacteria, which are specific spoilage bacteria for beef under modified atmosphere pack. But we didn't see any difference. We see a higher yeast count in the PHBV trays, but this is also caused due to the leakage that appeared in those packages. No? So we could say for the ones where we didn't have any leakage that they performed very well. Now, if their leakage appeared, invisible mold growth was also possible. Now, for the fresh beef, as already mentioned before, color stability of the beef is very, very important. And here you can see some pictures. Also, the black is the reference tray. I must say this is the reference tray from the lab because over there it's a transparent tray. But these ones are the black ones because of the deepness of the tray, which needs to be the same for the reference tray as for the PHBV tray. And the gray ones here, or the beige ones, are the PHBV trays. And we see that there is more discoloration in the PHBV material trays, which is not caused because of the leakage, which is also not caused because of the difference in gas measurements, not because of the oxygen availability, because we saw in the previous slide that was the same. What is the reason for that? We don't really know. We did some extra tests to make sure that it was not caused by the repacking of the beef in the PHBV trays, or that it was not caused by the transportation of the beef to the lab, because the conditions were a little bit different. We know for sure that that cannot be the reason. What might be a reason, but we are not sure at the moment, we saw that the top film didn't have an anti-fog layer, and that we had some condensation, some droplets over here on the top, that might have an influence on the discoloration of the beef. Then I will give the floor now to. Thank you. So I will show you the result on the cheese shape life. So just to remind you that I already presented this. We have a controlled packaging on the red column. So we use a PP cup, and for the liquid film, it's a metallized film, and there is a cover in injected PP. For the PHBV packaging, so we have the PHBV from commercial grade from Tian'an. And the liquid film, we use aluminium foil because we couldn't find something with a metallized, so biodegradable and metallized film. And we wanted to be sure that the sealing was perfect. So the aluminium with universal lacquer was there for this. We don't need any cover for the shape life. And we keep some fresh cheese. So we fill in the fresh cheese with herbs and garlics on industrial line. But as we already explained in the former presentation, we need to seal the cups on pilot line due to the risk of broken cups. So here are the results of the gas measurement. So we follow the dioxygen, the evolution of dioxygen into the space. So in black you have the PHBV cup. Sorry, there's no legend, but but it's always the same. And in white the reference one. But the important point is that there is no difference between the reference tray and the PHBV tray. It's due to the good barrier properties that we have seen before. For the microbial analysis or the chemical analysis, there's no difference between the reference and the PHB cup, so we won't go in detail, but it means that there won't be any evolution during the shape life, so it's a good result. And for the cheese, we had the opportunity to do some sensorial evaluation due to a huge amount of cups from first class. So we could fill a lot of cheese into the cups. So we have always the same control product and a PHBV PHBV cup with herbs and garlic cheese. And we follow the product during 80 days. And we perform some sensory analysis every 15 days with different panelists. And we also had the opportunity to do the light exposure test because we have cheese, and cheese are quite sensitive to light exposure. So we keep the cups with the cheese under light exposure for 72 hours. All the other shape life was performed in black condition. So here are the results of the sensory analysis. The main conclusion is that we have no difference between the reference tray and the PHBV tray for the main aroma items, global intensity, cream, butter, milky, herbs, garlic. So it's a good result. And in the table we have put only maybe some difference. The only one is the firmness of the cheese. We don't know why. It's a good question. We haven't the answer, and we couldn't repeat it to confirm this. So it's still a question. The line here is a result of the light exposure test, and here there is an oxidation defect for the PHBV cups. So that's the main difference, and it's quite it's a difficulty for using these PHBV cups like that. Okay, so we can round up with some take-home messages regarding the falafel. We clearly showed that there is no significant difference between the reference pack and the PHBV trays. For the fresh beef, it was the same for the gas measurements and for the microbial load. But of course, the discoloration problem which occurred still has to be solved. Which can for sure not be caused by too low oxygen concentrations. And then, as Florence mentioned, for the fresh cheese, also there, the PHBV packaging performed the same as the control packaging, except for the light oxidation. So to come back to our first question, what is the shelf life of the Glopack products in the PHBV-based packaging? I could say, as the other speakers, yes, but so it is comparable, and this is already a huge achievement, I think. But there are some points for attention, so as I mentioned before. So yeah, I would like to thank Be Natural as well, because they kindly provide us the top film. They are also here present today, so if you want to have more information on that top film, you can go to Erik to ask him some extra information. But I also want to thank the other partners of the consortium for providing us the food and for providing us the packaging material. And of course, I want to thank all of you for your attention.